This is for the momentum standard, and in this problem we have a baseball that weighs 0.15 kilograms and it is traveling at a velocity in the horizontal direction at 20 meters per second when a bat hits it and it goes straight up traveling at 15 meters per second. So it asks us to find the change in momentum, so the magnitude and the direction, and the force of the bat on the ball if it is in contact for 50 milliseconds. So to find our momentum, we're going to use the momentum equation, which is momentum equals the mass times the velocity. Now we have to do that at both the initial momentum and the final momentum. So we're going to take the weight and we're going to multiply that by the velocity. So our first velocity in the horizontal direction is 20 meters per second, which is going to give us a momentum of 3 kilograms times meters per second. And our second momentum is going to be the same mass times the 15 meters per second, which is our velocity traveling straight up, to equal 2.25 kilograms meters per second. Now to find the magnitude of velocity, what we're going to have to do is use the Pythagorean theorem. So we're going to square 3 kilograms meters per second plus square our 2.25 kilograms meters per second and take the square root of that. Now that just means that we're just taking those two values and finding the hypotenuse, which is in turn our magnitude of momentum. So we get our magnitude to be 3.75 kilograms meters per second. Now to find the direction of the ball for momentum, we're going to take the inverse tangent because we want to find the angle. And tangent is opposite over adjacent. So if theta is here, we're going to take the opposite over the adjacent, and we're going to get 36.9 degrees. So we have found our magnitude and our direction for momentum of the baseball. Now the second part of the question asks us to find the average force if the bat is in contact with the ball for 50 milliseconds. So we're going to take the equation F net equals delta P over delta T. We just found our magnitude and momentum, which is going to be 3.75 kilograms meters per second. And we're going to divide that by 50 milliseconds, convert that to seconds to be 0.05 seconds. Now when we do that, we're going to get a force of 75 newtons.